Here's problem 6 from the homework. In this problem, there's a car with two forces acting on it, and we need to add up those force vectors and then find the acceleration of the car. The problem gives you a sketch. It's essentially a free body diagram. Here's the car. We've got a coordinate system where they call the y direction forward. So if I label that y and x, y direction is the car moving forward. So there's this force F2 that is 30 degrees from the forward direction, and there's a force F1 that is 10 degrees to the left of the forward direction. So let's add those two force vectors. We do that by finding the components and adding them in component form. So let's look at vector F1 first. Draw a little picture of it. There's our 10-degree angle. Here's the y component, F1y. That is adjacent to the 10-degree angle. So that gets cosine. Here's F1x. That is opposite to the 10-degree angle. It gets sine. And furthermore, it points to the left. So we'll put a negative sign in front of it. Same thing for F2. Draw a right triangle. There's our 30-degree angle. F2, here's F2x. That is opposite to the 30-degree angle. It points to the right, so it's positive. And here's F2y. That's adjacent to the 30-degree angle. So it gets a cosine. Now we'll add those vectors together in component form. So the total force, F1 plus F2, in component form, that is F1x plus F2x, comma, F1y plus F2y. You have different numbers for your homework problems, so every one of you will have a different numerical answer for this. Now this vector is in component form. WebAssign wants you to express it in magnitude angle form. So as usual, to get the magnitude, we use the Pythagorean theorem. And to get the angle, notice that when you add these two vectors, here's your F2, F2, there's your F1, and the resultant is going to look something like that. So your resultant vector will be kind of like this. And there's some angle here. You can find that angle. It's the tangent of that angle, opposite over adjacent. The opposite side would be the x components, and the adjacent side would be the y components. So tangent theta is the x components of your resultant vector over the y components. So that implies theta equals inverse tangent Fx over Fy. And lastly, what's the acceleration of the car by Newton's second law? The magnitude of that acceleration is the magnitude of that net force, this F that we just calculated, divided by the mass of the car.